Hello. Today, we will talk about prime factorization. Now, prime factorization covers a variety of topics, including prime numbers, composite numbers, the LCM, and the GCF as well. Now, prime factorization can be quite a long word, and it can be quite difficult to understand what it exactly is. However, if we factorize the factorization part from prime factorization, we can determine that we have to factorize something. But what does the word prime mean? Well, in this case, prime refers to prime numbers. So essentially, in prime factorization, we're factorizing a number until it becomes prime. So what does prime numbers mean? Well, a prime number is any number that can be divided by itself and 1. A good example of this is 2. 2 can only be divided by itself and 1. Let's take another example. 5. 5 can only be divided by itself and 1 as well. We do not regard 1 as a prime number for technical reasons. Now let's talk about composite numbers. Composite numbers are numbers that can be divided by itself, 1, and any other number. 4 is a good example of this. 4 can only be divided by itself, 1, and 2. Another good example is 6. 6 can only be divided by itself, 1, 3, and 2. Now, on a test, if we're asked to factorize something, or factorize a number, it can take quite a while. However, I'm about to show you 2 tricks. The first trick is called the factor tree, and the second trick is what I like to call the table method. Let's first start with a factor tree. Now let's say we were given the following number, 28. How would we factorize this? Well, let's first start off with our factor tree method. So just like a tree, we'll start off with 2 branches. And let's think to ourselves, what is the lowest prime number that can be divided by 28? Well, obviously we do not regard 1 as a prime number anymore, so the lowest is 2. So let's put 2 on our left-hand side. And 2 multiplies 14 gives us an answer of 28. Now, because 2 is a prime number, we can no longer divide it. However, 14 is a composite number, and we can divide it. So let's divide it even further. Now, the lowest prime number that can be divided by 14 is 2 again. So let's put 2 on our left-hand side. And 2 multiplies 7 gives us an answer of 14. So let's put 7 on this side. So if we were to rewrite it, we could say the prime numbers of 28 are 2, 2 again, and 7. A good way to check your answer in a factor tree is to multiply the prime numbers together, and that can lead to your answer. So if we were to do it this way, 2 multiplies 2 gives us an answer of 4. 4 multiplies 7 gives us an answer of 28, and that was the original number which we started with. Now let's move on to the table tree method, which is a quite interesting method. So we'll once again start with the number 28. And we'll essentially make a T-chart. Okay, so let's think to ourselves again. The lowest prime number that can be divided by 28 is 2, so let's put that down. So we put 2 down here, and 28 divided by 2 gives us an answer of 14. So once again, the lowest prime number that can be divided by 14 is 2, so we'll put 2 here. And 14 divided by 2 gives us an answer of 7. Now, because 7 is a prime number, we can no longer divide it. So, essentially, the prime numbers of 28 here would be 2, 2, and 7. Well done. Now let's take another example, the number 40. So we'll start off with the tree method. So we'll put the 40 on the top. And once more, we'll have the 2 branches. Now let's think to ourselves, what is the lowest prime number that can be divided by 40? It's 2. So let's put 2 on our left-hand side. And 2 multiplies 20 gives us an answer of 40. So let's put 20 on the other hand. Okay, so 20 is a composite number, and we can divide it further. So once more, what is the lowest prime number that can be divided into 20? It's 2 once more. So 2 more branches leading out of 20, and we'll put 2 on the left-hand side. 2 multiplies 10 gives us an answer of 20. So we'll put 10 on the other hand. Okay, 10 is a composite number. So let's think to ourselves, the lowest prime number that can be divided into 10 is 2. Well done. So we'll have 2 on this side, and 2 multiplies 5 gives us an answer of 10. So we can write it this way. The prime numbers of 40 are 2, 2, one more 2, and a 5. So as I said earlier, we can check our work by multiplying all the prime numbers of 40 together and see whether or not they equal 40. So let's try it. 2 multiplies 2 gives us an answer of 4. 4 multiplies 2 gives us an answer of 8. And 8 multiplies 5 gives us an answer of 40. Well done. Now let's try the same number with our table method and see if we get the same answer. Okay, so let's start off with our number, 40. And let's draw a T-chart. Okay, so let's see. The lowest prime number that can be divided in 40 is 2. So let's put our 2 on this side. And 40 divided by 2 gives us an answer of 20. So we'll put 20 on this side. So let's think to ourselves one more time. The lowest prime number that can be divided into 20 is 2 again. So we'll put the 2 on this side. 20 divided by 2 gives us an answer of 10. So we'll put 10 on this side. And once again, the lowest prime number that can be divided into 10 is 2 again. So we'll put 2 on this side. And 10 divided by 2 gives us an answer of 5. And 5 is a prime number, so we can no longer divide it. Now, let's check our work. So, 40 equals the prime numbers 2, 2, one more 2, and 5. And if we were to check our work, we could do 2 multiplies 2, giving us an answer of 4. 4 multiplies 2, giving us an answer of 8. And 8 multiplies 5 gives us a final answer of 40. Both these methods are really cool. I hope this tutorial helped you with prime factorization, composite numbers, and prime numbers as well. In our next tutorial, we will talk about the LCM and GCF and determining the two within two numbers. For further comments, feedback, or questions, you can email me at lakhani@hotmail.com. And to check out some more videos, you can go to lakhanimoiz.wordpress.com. Thank you.